in this video some information about a project that I want to start, and I want to get this tube, cathode ray tube, into a working circuit. It is the B7S2 .01. It's made in the German Democratic Republic, so Eastern Europe, before the wall fell. Anyway, made by RFT. That's a big brand, very good brand. Made television sets, television tubes, cathode ray tubes, and many more things. And you can find a lot of information about RFT in Europe on the World Wide Web and on YouTube. Anyway, so this is the first ID. Cathode ray tube made in the DDR, etc., etc. I bought it in October 2009 for 7.50 euros. Well, that's not much, and the good thing is that it is very short. It means that the voltage to get this tube into working is not very high. It is going to the data sheet 1000 volts DC between anode and cathode, and of course we need a voltage divider to do more things anyway. So and when I say more things, I mean focus grid, brightness grid, etc., etc. I'm more or less sure that you can find all this information on the World Wide Web, but let me publish it. B7S2. Here is the tube in its glory, and here are the pin connections on the back side here, and they are very important, of course. And I want to show my first experimental ideas. Camera drops. Sorry for that. I want to show my first experimental ideas. Of course, I had to search in the, of course, to the data sheet, and here is that data sheet for everyone interested. And here it is all. It's in Dutch, by the way, but when you know a little bit about, these kinds of cathode ray tubes with electrostatic deflection, you will surely know what it's all about. Here are the plates. The most important things are here. Here is the cathode. Here is a grid for, limiting the electron beams that go to the anode. The brightness control, and here is the focus control, and well, etc., etc. So again, perhaps this can also help. When you want to make, for instance, a clock or so with such a tube. And here are my first ideas, and be aware my first ideas about how to connect the tube into a real working circuit. This will be the high voltage generator. It is here now, this one. High voltage generator made with an old school high voltage transformer, also made in the German Democratic Republic. Bought it in the past for 2.50 euros, but anyway, so this is the high voltage generator. It will serve the tube, and of course it is very important to read the data sheet, and the data sheet is here. Say we have, this is the most important, say this is the general data sheet here. This is all German, but anyway, you can surely see when you are a little bit acquainted with these kinds of electrostatic television tubes here. And here are, say, the working voltages. Get in touch with them, and here are the manufacturer, and here are the, say, absolute grenswaarde, so that the maximum voltages that this tube can handle. This beautiful tube here again can handle with all the pins here. I have to make connections, and I can advise you not to solder to the pins, because the glass can break when you heat up the pins too much. So make a kind of say, swirl around some copper and etc. Well, so here are the absolute maximum values. I hope they are visible, but out of this maximum values data sheet you can also derive, say, the voltages that are needed to serve this tube via all these pins. We are talking about the anode voltage, we are talking about the focusing voltage, and the brightness. The brightness is realized by a certain grid. So let's go back to my drawing. Brightness here. Here's the cathode, and here is negative, and the brightness voltage must be between 30 and 55 volts. So that means that you have a critical voltage divider here. This is a part of that voltage divider. It goes here and here and here. So the negative of the high voltage power supply, that's this one, is connected here to the cathode, and the positive is connected to ground, earth. So it means that we have between, say, the cathode a voltage divider that does the job with different resistor values here for focus, etc. And well, like I tell, this is the first idea, and I hope to give a real practical situation. And by the way, there is on my YouTube channel a series of videos, approximately 14 videos, where I have showed how to make a very simple oscilloscope going to approximately 40 kilohertz. That's not the aim in this case, by the way. I only want to make the tube in its most bare way. But say, back to the schematic. Well, the schematic tells it all. Here are the vertical plates. They are connected to ground. Here are the horizontal plates. They are connected to ground via a 1 mega ohm resistor. Could be that that resistor is too high, so that means that the plates are too sensitive. So perhaps you need 50 kilo ohm here or 50 kilo ohm here. Well, that are the first ideas when you want to make such a circuit. Let's go back to the official documents here. And here I'm more or less sure that you can find it on the World Wide Web. And well, like I told, here are, say, the standard voltages. The focusing voltage must be 200 microampere. That's not much. So a tiny girl will flow to grid 3. There is, say, information about correcting, say, the dot, the astigmatism. Anyway, I'm going to study that further. And again, here are the maximum voltages. And they also show, for instance, that the current to the to the face of the tube here, it must not be too high. 1.5 microampere to centimeters. Anyway, I hope it was a little bit interesting. Thanks for watching. Only, say, a basic first video about what I want to do. And well, again, thanks for watching. Getting this beautiful cathode ray tube here into functioning.